In this lecture, we'll begin talking about limits and discussing what they are. A limit's a new concept to us in calculus, and it's a little bit foreign, so pay attention and feel free to go back and rewind and look at this video again if you need to. The definition of a limit is right here, the working definition that we will use. L, the limit, is the number, so that means it's just one number, it's unique, that the function gets closer and closer to as x gets closer and closer to c. Now, this is the key part of the definition right here, closer and closer. That's what students most often have difficulty with, is what do we mean by closer and closer? So we're going to spend some time talking about that now. This is what a problem or the question would look like right here. This left side right here is normally what we would see as the problem, and we're trying to find the limit over here. That's our solution that we're looking. So we would read this as the limit, LIM standing for limit, as x approaches c, which would normally be a number, 2, 0, 5, of f of x, and that could be just written as f of x, or it could actually be a rule, 2x plus 3, 7x minus 9, x squared minus 4, cosine x, equals L. So normally a problem will be that we would give you this side of it, and we're asking you to find the limit. So again, that's read the limit as x approaches c of f of x equals the number L. Now let's move down to the graph here and talk a little bit about what we mean with that. We've got a graph here, and let's try to take our definition and match it up to what we're seeing on our graph here. So we've got it says L is the number that the function f gets closer and closer to as x gets closer and closer to c. So let's start off and look back here at x and c. All right, where is x on our graph? X is always the horizontal axis, so we're talking about x here, and it says as x gets closer and closer to c. So c can be any number on the x-axis. For this example that we're looking at, we're going to call 2 the number c. So if we were looking at this problem, this is how it would be written down. The limit as x approaches the number 2 of f of x. And that's the problem we're trying to solve. We're trying to figure out what is that number. Well, let's talk about what it means to get closer and closer. Here is the number c, and if we're going to get close to that number, we must be somewhere around it. Think about it just in terms of you and your friends. If you're getting closer and closer to someone, you are there in their proximity, you're close by, and closer, you're just moving towards them. So we're talking about an x number that is on the x-axis, it's down here somewhere, and it's moving towards c. So it could be to the right of c and moving to the left. It could be to the left of c and moving to the right. So that's what we're talking about as x gets closer and closer to c. We're moving towards the number c from the left or from the right. Now what's happening during that? We're asked to find out what f is getting closer and closer to. Well, where is f on our axis? Remember that y is the same thing as f for all purposes that we need to think about. So f, when you see the y-axis, that's the same as f, the function value. So as f gets closer and closer to, what is it getting closer? So again, closer and closer means we're moving somewhere on this line. We're looking for a number on this line over here. So our answer is always going to be a y number, somewhere up and down this line here. Well, how do we figure out what this is? Well, we're going to do just what the definition says and try to evaluate this graphically, okay? So let's start off, and we said x gets closer and closer to c. So what I want you to do is just take your pencil or your finger, and I want you to get on the function to the right of c. So let's say we're going to start off right there maybe, okay? And what did we say is going to happen? We said x gets closer and closer to c. So what I want you to do is, starting at this point, move towards c. That's going to be in this direction, but you have to stay on the function. You have to stay on this red line here. Now I don't want us to get to C, I just want us to move in that direction. So I'm going to trace it out just a little bit below it. So we're moving in that direction right there. Okay? Now, what is happening to F as we move there? So what I want us to do is, let's look. We have moved up this curve. We've gotten to this point right here. Now, what is the F value? What is the Y value that we're moving towards? If we take, it looks like we're moving towards this open circle here, doesn't it? So what I want us to do is just figure out, where is that leading to? That's coming right over here to the number 4. So it looks like, in our first look at this, we're thinking that the answer is probably going to be the number 4. That's because we started here to the right of C and moved back towards the left, and it looks like we're moving to 4. Is that the only place we could be close to C at? No, we could be on the left side of C. We could be over here somewhere and moving towards it. So let's look at that scenario. So again, we'll do the same process. We'll get on the curve somewhere over here close to C. And now I want us to take this and move towards C, but we have to stay on the curve. So we're going to stay right here, and we're going to come down, and we're moving towards a point. Again, it looks like we're moving towards this open circle, doesn't it? So since we're moving towards this circle, then where is that circle at? Again, if we look back over to the right, we can see, over to the left, we see that it's getting closer and closer to 4. So we looked at it from the right of C, moving towards the left back to C, and we got the number 4. We got to the left of C and moved towards the right, and we got the same number 4. So from that, we can conclude that the limit of f of x as x approaches 2 is the number 4. This is what we call solving these problems graphically. And that's one of 3 ways that we're going to have to be able to solve these. So solving graphically, that's the process we go through.